Now that we've gone through some basics of dividing, and especially dividing with fractions, we're going to look at some examples. So the first one is an example of what we call a job problem. Eventually, we're going to get to actually dividing with fractions, but for this example, we're just using whole numbers. And that's a little different from multiplication because if you multiply two whole numbers together, you're going to get a whole number. But it's not always the case that if you divide two whole numbers that you get a whole number. So in this case, we're going to divide two whole numbers in the problem itself. So on first glance, it's not going to look like it has anything to do with fractions, but it actually has a fractional answer. So this is going to be a painting project. We're going to say a painting project requires 2 gallons of paint per wall. And we want to know how many walls can be painted with 7 gallons of paint. And we're not going to write story problems. We're going to mostly focus on solving these. But if you were going to write a story problem here, knowing ahead of time what type of answer we want would be important. So in this case, I do want a fractional answer. So I'm going to indicate that here. I'm going to say how many walls can be painted, including fractions of a wall. So if you come up with a story problem for students and you're okay with fractions, state that. Right, so this might be obvious to some students that you're doing a division problem here, but it may not be obvious for all students. So when that happens, we would go ahead and help students along by having them fill in the blanks in a setup equation. And this is good for us to get some more practice with this anyway. So when we do a setup equation, it's going to be a multiplication setup, even if it ends up being a division problem. The setup would be multiplication. So I'm going to put some blanks in, and then I'm leaving some space after my blanks to put in my units. So we've gone through this before, but the way I like to do this is I like to come up with what my 2 units are in the problem. So in this problem, one of the things they mention is gallons, and the other thing they mention is walls, right? So those are my 2 units here. And so I like to start with the second number in my problem. So I've got one number times another equals some answer. So I'm going to start with what I'm multiplying by here, the second number. And I know that both units are going to go on that number. So in this case, since my units are gallons and walls, this either has to be gallons per wall or walls per gallon. And so then it's just a matter of asking yourself what makes the most sense. In this case, it makes the most sense that I would know or find how many gallons it takes per wall. So gallons per wall makes the most sense. Once you decide what the units are, the correct units are on the second number, whatever comes after the word per, that unit is going to go on the first number. So I know the first number is going to be in walls. And then whatever word comes before the word per is going to be on my answer. And sometimes I'll write the word total. But if you didn't say total gallons, if you just said gallons, that's perfectly fine. And so this is the point where I might introduce it to a student and have the student see if they could kind of fill in the blanks here. So the first number that they gave me in this problem was 2 gallons of paint per wall. So that's gallons per wall. So that would go here. And then the other number they gave me was 7. And so we're trying to find how many walls can be painted with 7 gallons of paint. So 7 is in gallons. So I actually know the total. What I don't know, and where I'll put my question mark, is the number of walls. That's what I'm trying to find. So this is my setup multiplication problem. And then from this, if I'm trying to figure out what times 2 equals 7, the only way to figure that out is to do 7 divided by 2. So not that you'll have to write it, but just with the basics of what it means to divide, we can say an equivalent division equation would be 7 divided by 2. So that means that I'm going to divide 7 by 2, and you could use whatever method you like to solve or draw pictures or however you want to do that. In this case, I would maybe just go ahead and go through my long division and say 2 goes into 7 3 times. 3 times 2 is 6. Subtract, and I get a remainder of 1. And then if I wrote that as a fraction or as a mixed number, this would be 3 1/2. So I can see my answer in this case, my fractional answer, even though I started with whole numbers, would be 3 1/2. 3 1/2 what? In this case, we were finding the walls. And you might be like, well, why would you paint half a wall? Well, I probably wouldn't. I'd probably go back to the store, but at least I know how many walls I could paint. I could paint half a wall in theory, so that's an okay answer here. So 3 1/2 walls, if it's a story problem, we always put those units on it. So this is a good example of, we started with whole numbers. It didn't necessarily look at first like we were going to run into fractions, and yet we did, right? So this is a division problem where we end up with a fractional answer. But this actually brings up a good question, and that is, when does this type of fractional answer make sense? So there's actually an old movie, if you like Medea movies, there's one from 2005, which was called Diary of a Mad Black Woman. And in that movie, there's a couple that's going through a nasty divorce, and they're arguing over things. And so the character of Medea, she comes into the room, and you just hear this loud noise, and you go into the room and you see that she's got a chainsaw, and she's in the back of the couch, and she's saying, well, which half do you want? You want this half or you want this half? And she chainsaws the couch in half. And so if I turn that into a math problem, we would be saying, okay, we've got one couch divided by 2 people. And of course, 1 divided by 2 equals half. So in this story problem, it would be half of a couch. But of course, who wants half a couch, right? So that was the answer according to Medea, but that type of answer doesn't really make sense. So we're going to look at a couple other types of problems where really that fractional answer doesn't make sense. And to do this, I'm actually going to use the same exact numbers. I'm going to do, we just did 7 divided by 2. I'm going to do 7 divided by 2 again, but I'm going to change the story problem so that you can see how this wouldn't necessarily be a fractional answer. So there are times when fractional answers make sense, but other times when they're inappropriate. And when that happens, we need to either round up or round down, depending on the story problem, in order to be fair, in order to make it make sense. So let me give you a couple more examples. So this next one, let's say Anthony has 7 stickers that he wants to share. If you're writing story problems and anytime you're splitting things, make sure you say equally or evenly. That's an important word to put in there. Let's say he wants to share evenly with his brother. And so sometimes it makes sense from the context, but honestly, it makes the most sense what type of answer we're wanting based on how you ask it. So I would ask, how many stickers will each boy get? And if we think about the way that we asked the last one, we asked, how many walls, including fractional walls? So if I ask it that way, if I say, how many stickers, including fractional stickers, will each boy get? Technically, I would get a fractional answer. However, who wants a fraction of a sticker, right? And so this is a situation where it really doesn't make sense to get a fractional answer. So I'm going to specifically ask my question in a way that makes more sense as well, right? So hopefully it makes sense if I even asked it this way. Hopefully most people would say, well, each boy gets 3 stickers. But I'm going to specifically say, how many stickers will each boy get? And then since I know I don't want a fractional answer, I'm also going to ask for the leftover. So I'll ask, and how many will be left over? So by asking it this way, we're indicating that we don't want a fractional answer. And so even though this is the same problem, this is still 7 divided by 2. I have 7 stickers divided among 2 boys, right? Even though that's the case, my answer is not 3.5. In this case, it would actually be 3 stickers each with 1 left over. So in this case, I wouldn't actually list my answer as a mixed number. I would actually list it as the quotient and the remainder, right? And this is what I refer to as a round down situation. So our first example was a fractional answer, right? And then this one is a round down. And then just to show one more type here. So I'm going to do another example, another story problem for 7 divided by 2. Let's say Megan needs to carry 7 boxes home from work. But she can only carry 2 boxes at a time. And so I want to know how many trips, right? If you write this type of story problem, be really specific here. If you just said, how many trips must Megan take? Some students are going to interpret that as you mean the trips that she's taking boxes from work to home, but also the trips that she's going back to work to get more boxes. So you want to be really careful and really specific if you write these. So I'm going to say, how many trips must Megan take from work to home? Not worry about return trips to get more boxes. I want this to be a problem for 7 divided by 2. So if I included trips back to work, that's not really 7 divided by 2. We'll say in order to get all boxes home. So in this case, it's still 7 divided by 2, right? We have 7 boxes, dividing that by 2 boxes per trip. I want to know how many trips it's going to take, but you can't take half a trip, right? So a fractional answer of 3.5 trips wouldn't make sense here. And rounding down to 3 wouldn't make sense here because 3 trips would get me all the, not all the boxes home, it would get almost all of them, right? But I'd still have 1 box left. So in this case, I would actually answer 4. So this is what I call a round up situation. And it's just based on the scenario, right? The scenario is what determines what makes sense. In this case, it makes sense to round up because you're going to have to take 4 whole trips, even though in that last trip you're only taking 1 box instead of 2. All right, so then we're going to do 3 more examples to finish out this section of notes. And those 3 examples are going to be yours. So I want you to come up with your own. I want you to come up with a fractional answer story problem. A round down story problem. And a round up. I want you to write 3 separate story problems, and all 3 story problems I want to be for the problem 13 divided by 4. So that means that to your first story problem, the fractional answer, your answer should end up being 13 divided by 4 would actually be, 4 goes in 3 whole times with 1 left over. So that would be 3 and 1/4, right? And then put units on that. But then for your round down situation, your answer should be 3 with a remainder of 1 or 1 left over. And then for your round up situation, you would actually round it up to 4, right? So I want you to come up with 3 story problems. And when I check your notes, I'll look for these. So write those 3 story problems. You don't necessarily have to write them in any order. I think the easiest way to go about this is to just write a story problem for 13 divided by 4, and then decide which of the 3 types it is, and then see if you can tweak that or come up with a different one to meet one of the other ones, right? So if you just label which one's which, that's perfectly fine. So come up with 3 story problems, fractional answer, round down, and round up for the problem 13 divided by 4.